Okay, now we will solve the questions, direct application. So in each case, we will get the work, the force, or the distance. The only thing that we need to check or to make sure that we have is the factor that we need to make sure that the force and the distance that we have are parallel to each other and not forming a right angle, since we're using the simplified formula, which is force into distance only. Okay, so question A, calculate the work done by a 47 Newton force pushing a pencil 0.26 meter. Please, in each question, pause the video, try to solve it alone, and then check my answer. Okay? So, first question is pretty easy. We just have the force and we have the distance. So, applying the rule, you will say work is equal to the force multiplied by the distance. So, it's 47 multiplied by 0.26. And so we will have work is equal to 12.2 Newton meter. Okay. In question B, we need to calculate the work done by a 47 Newton force that is pushing a pencil, a 0.025 kg pencil, 0.25 meter against a force of 23 Newton. So in this question, we have a pencil, and this pencil is pushed by a force of 47 Newton. But there's another force acting against the force that we're applying, and that force is due to friction to the pencil against the table, friction force. So in such case, in order to know how to calculate the work, we will say work is equal to the force multiplied by the distance. But which force are you gonna take? In fact, the force that you need to get or to take into consideration is the net force acting on the object. So the net force acting on the object is equal to 47, but this force that you're applying is reduced by 23 due to friction. And so the net force applied on the pencil is 24 Newton. So it's 24 Newton multiplied by the distance, that is 0.25 meter. And so the work done is equal to 6 Newton meter. In question C, we need to know how much work is it done to lift a 20 kg sack of potatoes vertically 6.5 meter. So we have the system, and the system, we're applying a force upward in order to lift the object. Now, in order to be able to lift an object, we need to apply a force that is equal to the weight force of that object, but in the opposite direction. If the sack has a mass of 20 kg, then it has a weight of 200 Newton. So in order to be able to lift that, we need to apply a force that is equal to 200 Newton, but in the opposite direction. And so the work done is equal to the force multiplied by the distance. And the force in such case is 200 Newton multiplied by how much distance we're displacing the sack. So it's 6.5. And that will give us 1,300 Newton meter. So why did we use the mass in this question and we did not use it in this question? Right? Some people might be confused. Why didn't we use the mass in this question? That's because in the pencil question, if I take my pencil, okay, and I know that the pencil has a mass of 0.025 kg, so it must has a weight of 0.25 Newton. So I just multiplied this by 10 to get the weight. But the forces that we're applying here are the 47 Newton, and there's an opposite force of 23 Newton acting against it. So now we have three forces, okay? But in order to decide which one is exerting a work, we need to check the second factor that the work depends on. If we have forces, does it like this force, does it make the object move by a distance? And so if you check the force acting on the y-axis, the 0.25 Newton, the downward force, you would see that this force does not have any displacement. So D is equal to 0. This force couldn't displace the pencil by any distance. So the work done due to gravity or weight is equal to 0, and that's because no distance was done. But in this case, this question, the force that we applied on the object to lift it is an equal force to the weight, but in the opposite direction. And this force that we applied, it does have a distance. So this force that we applied could make a distance upward in parallel to it. And so we need to take it into consideration. Okay, question D. Brenda carries an 8 kg case as she walks 25 meters long, a horizontal walkway to her room. And how much work does she do in carrying her suitcase? Now, Brenda's case is very similar to the case that we took before in Stickman, which is picture E. Okay? So Brenda is actually exerting a force on her case, but this force is upward. And the walkway that she's walking is forward, horizontal. So again, we have a force and we have a distance, but the force and the distance are perpendicular to each other. They're not parallel. In such case, work is equal to 0, and we say that no work was done by Brenda. Question E. If a small motor does 520 joules of work, joules or Newton meter, okay? To move a toy car 260 meters, what force does it exert? So now we need the force. Applying the rule, we can say that force is equal to the work divided by the distance. Okay? And so we will say force is equal to work over distance. So that's 520 over 260. And so it's 2 Newton. Question F, we have a girl that is pushing her little brother on his sled with a force of 300 Newton for 750 meters. How much work is the force of friction? How much work is this if the force of friction acting on the sled is 200 Newton? Once again, this is my system. The force applied by the girl is 300 Newton, and the force of friction is 200 Newton. And the object was displaced in this way with a 750 meter. So there is a force and there is a distance, and the force is parallel to the distance, but we need to get the net force. 300 minus 200, that's 100 Newton. So now work is force multiplied by the distance. So it's the net force that we got multiplied by 750. That's 75,000 Newton meter work done by the little girl. Question G. A 75 kg man is pushing on a wall for 250 seconds, but the wall does not move. How much work does he do on the wall? Well, this man will get tired, but in terms of physics, he did not do any work. That's because work depends on both force and distance. If the man is applying a lot of force onto the wall, but the wall did not move, and then no work was done at all, so it's 0. In question H, how far can a mother push a 20 kg baby carriage using a force of 6.2 Newton if she can only do 2,920 joules of work? Joules is another unit for work. You can still use Newton meter until we continue with the material and you understand the relationship between work and energy. So now we will return back to the triangle. We want to get the distance. Distance is going to be equal to the work divided by the force. So applying the rule, we will say D is W over F, that's 2920 over 6.2, that's 471 meter. Question I, a force of 100 Newton was necessary to lift a rock. A total of 150 joules of work was done. How far was the rock lifted? Again, we need the distance. It's work over force. So it's 150 over 100. And that's a distance of 1.5 meter. Now, last question is very important and challenging. In this question, that's like a multiple choices question. Okay, so this is the formula that we know. We have a man that is pulling a cart up a hill, so he's exerting a force in this direction, and this force is 200 Newton. Consider that it's frictionless, so there's no opposite force acting on it. And we want to get the work done by the man. And since he's going up a hill, I gave you the length of each side of the hill. It's 2 meter height and 4.5 meter side, and the hill is 5 meter upward. In order to calculate the work done, we need to know which distance are we going to take into consideration multiplied by the force. Well, in order to be able to answer that, we need to check the third important factor, which is that force should always be parallel to the distance. In order to consider that there was a work done, the force and the distance must be always parallel to each other. So in such case, the man work would be the force 200 Newton that he's exerting multiplied by the parallel distance to it, and the parallel distance to the force in such case is this one. Okay, so it's answer B, 200 times 5 meter, and you get the answer of the work in Newton dot meter. Okay, so these are the answers. Now, to sum up everything, what we took is that the work is the force that moves, so it depends on the force and the distance. Force is in Newton, distance is in meter. In some situations, work is considered as 0. The situations where a person is holding an object and walking forward, so in the situations where the force and the distance are perpendicular to each other, there's no work done because work should be parallel to the distance. And the second case is when one of the factors is 0, either the distance or the force. Well, it's always the distance because if there's no force acting, so there's no distance acting. But sometimes we do have a force acting on an object, but that object won't move like the ball. So in such case, once again, the man is considered as not doing the work anymore. Third thing that we know is that if we want to get the work done, we need to choose the force multiplied by the parallel distance to it. So in this picture that we have, the parallel distance to the force would be C. So we multiply the force by the side C in meter to get the work. Last thing that we know is that when we have more than one force acting on the object, we always need to get the net force before proceeding to get the work done by one of the boys acting on the box. Okay? So that's all about work. Part 2 of the lesson would be energy.